Okay, hello everyone. Let me introduce myself. My name is KETUT Laksmi Dewi. You may call me Laksmi. I'm from class 4D and my last ID number is 0, 7, and 6. And this presentation I will talk about topic 12, which is the concept and application of transformation. In this session, I will explain what a transformation is, how we describe it using notation and coordinate rules, what types of transformation exist, and where we use transformation in real life. I will also use some important topic, and so please pay attention because it is very important for us. Okay, before we start, let's think first. I want to ask you a simple question first. When you look in a mirror, your reflection has exactly the same size as you. But is your reflection in the exact same position as you? Please think about it for a moment. The answer is no. Your reflection is flipped and appears on the opposite side of the mirror. This simple idea, shape changing its position or orientation without changing its size, is exactly what we call a transformation. That is what we are going to learn in this video. Now, let's talk about the definition. A transformation is a process that changes the position, size, or orientation of a shape on a coordinate plane. When we talk about transformation, there are two important terms we must know. The first is the pre-image, which is the original shape before it changed, usually labeled with letters like A, B, or C. The second is the image, which is the new shape after the transformation happens. We write the image with a small mark called a prime symbol, for example A accent, which we read as A prime. It is important to remember that some transformation only change the position of a shape, while others also change its size. Next, let's learn how we describe a transformation using proper notation. First, we can use mapping notation such as a maps to A prime, which simply shows that shape A becomes shape A accent. Second, we can use a coordinate rule such as x, y maps to x plus A, y plus B, which tells us exactly how every point moves. We also need to understand two more important terms. The center of rotation is the fixed point that a shape turns around, and the line of reflection is the mirror line that a shape flips across. Let's look at an example. The rule x, y maps to x plus 2, y plus 3 means every point moves 2 units to the right and 3 units up. And so if point A is at 1, 1, after the transformation it becomes A accent at 3, 4. Please remember these vocabulary words: pre-image, image, coordinate, mapping, center, and orientation. Now, let's move to the 4 types of transformation that you must know. The first is translation, which slides a shape from one place to another without turning it or changing its size. The second is reflection, which flips a shape across a line just like a mirror image. The third is rotation, which turns a shape around a fixed center point. And the fourth is dilation, which enlarge or shrinks a shape from a center point. Understanding these four types will help you to recognize transformation more easily in different mathematics problems. And the next, after knowing the four types, let's look at the coordinate rule behind each one. For translation, the rule is x comma y becomes x plus a comma y plus b, and then this means we save the shape by a units horizontally and b units vertically. For reflection over the x-axis, the rule is x comma y becomes x negative y. The y coordinate changes its sign while the x coordinate stays the same. And notice that the coordinate sweep place with a sign change. And for dilation with a scale factor k, the rule is x comma y becomes k times x comma k times y. Every coordinate is multiplied by the same scale factor. These formulas are the mathematical recipe for each transformation. Now, let's talk about why this topic is important. Where do we actually use transformation in real life? First, in animation and film. Animators use translation and rotation to move characters smoothly, frame by frame. And second, in architecture and design. Architecture use reflection and dilation to create symmetrical building plans and to scale their design up or down. Third is in art and pattern design. Artists repeat transformer shape to create beautiful translation and decorative patterns. And fourth, in robotics and technology. Robots use rotation and translation formula to move and position their arms precisely. So, can you think of another example from your own daily life where transformation might be hiding? Okay, let's practice reading a mathematical problems written in English. Here is the text. Triangle ABC has vertex A. One has this data and find the image after the translation of this. Let's solve this together step by step. First, we apply the rule to each vertex. We add 2 to the x coordinate and we subtract 1 from the y coordinate. Second, applying this rule, point this becomes a accent and point B becomes B accent, etc. And point C becomes C accent. And third, notice that with the new triangle, A accent, B accent, and C accent has exactly the same size and shape as the original triangle. It has only changed its position. And yeah, let's summarize what we have learned today. Number 1 is a transformation change a shape, position, size, or orientation. Number 2, the original shape is called the PD image and the new shape is called the image. Number 3 are 4 important types of transformation is translation, reflection, rotation, and dilation. And number 4, each type of transformation follow its own coordinate rule, such as x comma y becomes x plus a comma y plus b. And number 5, transformation are widely used in animation, architecture, art, and robotics. And I hope this summary makes the concept clearly for you, both mathematically and in terms of English vocabulary. Okay, thank you for your attention and see you.